Welcome to episode 17 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
You don't need to be a statistician, but you need to speak the language.
That's right. Statistics is the backbone of data analysis, and understanding a few core ideas can really boost your confidence when discussing data-driven projects and AI initiatives.
Let's start with the basics. Statistics is essentially the science of understanding data. It helps us summarize large amounts of information and draw meaningful insights.
Totally. In business, you're not just staring at numbers. You're trying to answer questions like, what's typical? What's unusual? How sure can we be about a trend?
Exactly. And to do this, statistics relies on concepts like distributions, averages, and variance. These might sound technical, but they're all about describing data in ways that are easy to understand.
Distributions. That's one I found really helpful when talking to non-technical stakeholders.
Let's unpack that. Think of a distribution as a map showing how data points spread out. For instance, imagine you collect test scores from a class. The distribution tells you how many students scored in each range.
So it shows the shape of the data.
Exactly. It answers questions like, are most scores clustered around the average, or is there a wide spread with lots of variation? Are there outliers, scores very far from the rest?
In working with sales data or customer behavior, understanding the distribution helps us know if we're looking at a typical trend or something unusual.
Right. For example, if most customers spend around $50, but a small group spends over $500, the distribution shows that skew, which affects how we interpret averages.
Which brings us nicely to averages, the most familiar statistic in business.
Indeed, the average, or mean, is the sum of all data points divided by the number of points. It gives us a central point, a typical value.
But averages can be tricky, right? I've seen teams get blindsided when the average masks important differences.
Yes, the mean can be deceptive if there are outliers. For instance, in income data, a few billionaires can raise the average income far above what most people earn.
That's why sometimes median is better measure. It's the middle value when data is sorted and less affected by extremes.
Precisely. The median shows the point where half the data lies below and half above. It's another way to summarize the central tendency.
In healthcare projects, like analyzing patient wait times, we often use median because a few very long waits can skew the mean.
Now let's talk about variance and its close cousin, standard deviation. These tell us about the spread, how much data points differ from the average.
That's the part that tells you, are your numbers tight around the average or all over the place?
Exactly. Mathematically, variance measures the average squared difference from the mean, giving a sense of dispersion.
And the standard deviation is just the square root of that, which brings it back to the original units, making it easier to understand.
Right. If the standard deviation is low, data points are close to the average, more consistent. A high standard deviation means data is spread out.
I find this super practical in manufacturing. Say you're tracking the diameter of parts produced. If the standard deviation is high, it means inconsistency, and that signals quality issues.
Exactly. Variance and standard deviation are essential for quality control, risk assessment, and even predicting outcomes.
In finance, for example, the variance of investment returns helps assess risk. A portfolio with high variance is more volatile and riskier.
Let me give another analogy. Imagine you're planning a picnic and looking at weather forecasts. The average temperature gives an idea of what to expect, but the variance tells you how unpredictable the weather is.
So if the variance is high, you might want to bring a jacket and sunscreen, prepare for surprises.
Precisely, and that's why businesses love variance. It helps manage uncertainty.
Now, Jonas, how do distributions, averages, and variance connect in practice?
Great question. The distribution shows the overall shape of data. The average locates its center. Variance measures how spread out the data are around that center. Together, they give a full picture.
Got it. In retail, for example, if you look at daily sales, the distribution tells you what a normal day looks like versus a fluke.
And knowing the variance helps forecast future sales ranges, essential for inventory planning.
Exactly. Just last year, I worked with the car dealership looking at monthly sales data. They saw an average of 200 cars sold, but the variance showed months swung wildly from 150 to 300.
So relying on the average sales alone would have led to poor stock planning.
Right. They adjusted their strategy to prepare for that variance, improving customer experience and reducing costs.
Another important point is the shape of the distribution. Many statistical methods assume a normal or bell-shaped distribution.
I've heard that term a lot. Why is the normal distribution so important?
Because many natural phenomena follow this pattern. Exam scores, heights of people, measurement errors. It has predictable properties, which simplifies analysis.
But not all data are normal, right? I imagine retail sales or website traffic can be more irregular.
Correct. When the data are skewed or have multiple peaks, we need different tools. But understanding the concept of distribution helps us choose the right methods.
I've seen companies struggle when they apply techniques assuming normality only to get misleading results.
This reinforces how important a basic grasp of distributions is for anyone working with data.
Before we wrap up, let's talk briefly about why these basics matter for AI and machine learning.
AI models often start by analyzing statistical properties of data. Understanding distributions, averages, and variance helps in feature engineering and setting expectations.
In practical terms, when I'm advising companies, I emphasize cleaning and exploring data first. You can't build good AI on messy or misunderstood data.
Well said. Statistical literacy lets you ask the right questions. Is this data representative? Are there outliers? What variability can we expect?
And those questions save time, money, and help build trust with stakeholders.
To summarize our key takeaway, statistics is not just about numbers, it's about interpreting the story data tells. Distributions, averages, and variance give you the vocabulary to understand that story.
My takeaway, these stats tools are your toolkit to spot risks, opportunities, and realistic expectations. Knowing them turns data from confusing to actionable.
Next time, we'll dig into data mining, how businesses extract useful patterns from vast data pools. It's where statistics meets discovery.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your questions or comments. Your input might even get featured in an upcoming episode. Until tomorrow, stay curious, stay data-driven.